An RL circuit consists of a resistor of 68 ohms, an inductor of 31 millihenry, and an AC generator with an RMS voltage of 120 volts. In the first part of the problem, you need to find at what frequency will the RMS current in this circuit be equal to 1.5 amps. Let's see what the problem gives us. It gives us the resistance, the inductance, the RMS voltage across the generator, and the current in the circuit, 1.5 amps. We need to find the frequency. Frequency is calculated as the angular frequency omega divided by 2 pi. We do not know the angular frequency, but we do know that the angular frequency is related to the inductive reactance XL. XL equals omega angular frequency multiplied by the inductance L. As you can see, if we can find XL, we can calculate omega. How can we find XL? Well, the resistance and XL are related to each other in the definition of the impedance. The impedance Z equals square root of the resistance squared plus inductive reactance squared. Now the problem is we can find XL if we know the impedance, but we don't know the impedance, but we can calculate the impedance. The impedance relates the RMS voltage across the generator to the current, and we know that Vrms equals current RMS multiplied by Z. So from this equation we can find the impedance Z as the ratio between the RMS voltage and the RMS current. RMS voltage is 120 volts and RMS current is 1.5 amps, and we get a value of 80 ohms for the impedance Z. Now, since we know the impedance, we can go back into this equation and find XL. For that, we will square the entire equation and isolate XL. XL squared will be equal to Z squared minus R squared. All we have to do is plug in the numbers. The impedance is 80 ohms, don't forget to square it, minus the resistance is 68 ohms, don't forget to square it. And we obtain a value of 42.15 ohms for XL. Now that we know XL, we can go back in the next equation and find the angular frequency omega. Omega will be equal to XL divided by L. XL has a value of 42.15 ohms and the inductance L is 31 millihenry or 0.031 henries. And that gives us a value of 1360 radians per second for the angular frequency. And finally, we can go in the first equation and find the frequency. That will be equal to the angular frequency 1360 divided by 2 pi or 220 Hertz. This is the frequency at which the RMS current in the circuit has a value of 1.5 amps. Now for the second part of the problem, we need to find the RMS voltage across the resistor and across the inductor for this particular frequency. The RMS voltage across the resistor is calculated as the RMS current multiplied by the resistance. And in this case, all we have to do is replace the current with 1.5 amps and the resistance with 68 ohms. And we get that the RMS voltage across the resistor is 102 volts. The RMS voltage across the inductor will be equal to the RMS current through the inductor, which is the same as the RMS current through the resistance and through the entire circuit, multiplied by the inductive reactance XL. Again, we replace the current with 1.5 and XL with 42.15 ohms. And we get that the voltage across the inductor has a value of 63.225 volts.